Welcome to the GATE video, and now I am just going to encourage you to meet with a major and important topic on GATE coaching. That is, the first one is about programming and data structure, and particularly why I am taking this topic is, as you know that as a computing student we should have a good knowledge in data structures, because major areas in IT industry is focusing on data structures, and in that particular thing we need to learn about stack. And today I am going to explain you about the stack features and where it is applied and when it is going to be an important factor in the GATE presentation. So let's move on to the stack implementation. And myself, A.M.SERMAKANI, and Associate Professor in IT Department, SA Engineering College. And here we are encouraging students to learn GATE through our presentation like this video. So major part of the syllabus will be covered through this GATE video, so that students can have a motivation and encouragement to fetch on through the videos, and they can prepare their GATE exams. So that's why we are focusing on different areas of GATE syllabus. And today I am going to concentrate majorly on programming and data structure, and today the topic is stack. So as you know that stack implementation is applied in every day-to-day life, that is a real-time world, that is of because even through the movie ticket booking centers and other online platforms, they majorly concentrate on stack implementation, because once we have booking scenarios, then later on that implementation should further replied through their app. So this is forwardly and applied mainly through the stack implementation. So let's move on to the content. First, the stack is a linear list. It was implemented via the linear list, and the major part is applied with the approach called last in first out. So what is the meaning of that LIFO? So abbreviately we can say that as a LIFO. So last in first out, what is the major thing? So when I am doing the stack operation, the major part of the data will be fetched with the bottom level, and the major part will be fetched through the top. So when we have a data in this linear list, the topmost data should be pushed out, and that the list will be enhanced with the pop and push operation. So this is the way how the stack is implemented. And here when we have the data to be in the last level, the fetching of data, that is going to be the first level in the stack, and then later on the data should be the last level, they have to be pushed. So this is the scenario that happens in the stack. So here when we thoroughly see about last in first out, the major part is the pop and push level. So here I am just going to give you through the example. So here I am just giving you 4 elements. The first element will be the 6, and this will be the first pushed through the stack, and here this is the first element, and second element is the 7, and third element is the 2, and fourth element is the 3. So for us it will be the fourth element, 3 is the fourth element, but when we are fetching or pushing that, the popped element will be the first element, that is 3. So this application focus mainly about last in first out scenario, because when we have an insert and delete operations in the major applications like the postfix impression, infix to postfix, all these expressions, they focus mainly through the stack. So this is because when we have an element to be read out with the last element, then definitely we should use the stack. So here in GATE syllabus, they mainly given the importance to learn about the stack implementation, because every platform, that is a real-time IT industry sectors, they depends on the stack application. That's why they given this syllabus. So here I am just going with a proper level of implementation, like starting with the introduction, and then this is our example where we can imply these applications. Say for example, here I just make a note of a tray concept. So when we implement the stack of trays, so here I am having even 10 trays or 20 trays. So when we place this, the platform should accept the last in first out, because I cannot move the trays with a bottom level approach. We should take out from the top level. So in these scenarios we should definitely use the stack, and majorly here the stack of pennies, this is the second implementation, and this is the third one, that is the boxes. When we are arranging the boxes, definitely it should follow the stack level, because the bottom level boxes we cannot be removed. So the first one should be removed and the last in first out approach should be applied here. And here we are arranging the shirts. So these are the different level of stack arrangements, and you can easily understand through these portraits. That's why I have given these figures. Next, when we have the definition, so this is our major part. So there is, I told you there is a two operations, push and pop. So first one, push implemented through the first level of inserting the element, that is adds an item to the top of the stack. So we are maintaining the position as top. In stack it was meant to be a top, and then pop, this is removing the stack elements, and this will be returned to the user with a proper approach. So we are mainly focused on the top approaches. And this is the major operations like push and pop, and this is an example. So this example portrays how the pushing is happened in the stack. So first I am just giving you the example with the 5 elements. Say for example we take 6, 10, 20, 30, 40, 50 and 60. So these are our elements that is to be inserted through the stack. So first, this is our example. First time the step 1 procedure will follow with the pushing of 10, then 20, 30, 40, 50 and go on. So here this is our picture implementation, how it is implemented. So for example, the 10th will be, even though it is a 10th element, now it goes like a last element. That is the first element, then second, third, fourth. Likewise, now we are fetching each and every element. When considering each element, this is the top position. So top position means that it was the last element to be fetched. For example, here this 40 mean to be a top, which means that when I am making the pop element now, then the 40th element, that is a 40 will be popped out. The top position, topmost position of the element to be popped out. This is the meaning of the position called top. Next, we talk about the popping of elements. So I mentioned you like if you wish to have out of that is a popped element, now we need to concentrate on 40. That will be stacked first and it will be last in first out. So the 40th element will be now move on. So next 30. So here I just mentioned how it will be given: 40, 30, then 20, then 10. Okay, so here this is the example view of stack implementation. Now I am just going to explain you how it is implemented through the programming structure. See, as a programmer, as a IT sectors, they will use all these methods to implement the data structure concept. So here there is a few content, that is a method name that should be implemented through the programming structure. First, I just give you the is empty. So is empty should be majorly important because we need to check out whether the stack is free or it should be have a add-on elements. So first we have to enhance with the is empty. It should check for the emptiness, that is data will be empty at that, and we need to give the insertion operation, the second step. Now the second is full. So now we have to check whether the given stack is full or not. So this will be processed if you check with this method. Then push. So this is our major operation in the stack. So here there is a two parameters. One is yes and another is item. So yes is mean to be the stack and item is what we are going to push it. So in previous example we have given 40, 30, 20. So likewise we have an element that we need to be inserted. That element to be given here in the push method. Then pop, we have a pop yes. So stack is the only parameter. Here we don't want the item to be given as a parameter because we as you know that the first last element to be popped out. So if you give the stack name alone, that is enough that the last element is always fetched out first. So this is the parameter, that is the only parameter that passed through the pop method. Then clear. Clear gives you the entire stack to be emptiness. So here wherever stack, whatever elements there, everything will be emptied now. So that is a clear. Then item top and item top and pop. So here we need to check which item is popped first, which item is pushed first. So all these will be given through the parameter called stack yes. So these are the methods definitely we need to implement it through the programming papers. And now I just want to give you the sample example that how they are implemented. Say here First one, I am just giving you the allocation in the memory location through the method called malloc size of stack. So when I am giving the stack size, automatically it fetches the entire stack size into the memory allocation. So the memory will now get switched on to the particular stack. Say for example, here I have given the variable yes. So here the entire stack should be processed with a name called S. Okay. And here it is a S of A. So this is our first element A, then second element B, third element C. So now I am assigning those top element as in the case of D. So now D plays the vital role of carrying that last element, that is C. Then pop of S. So now if I am giving the pop of S, now in the memory called D, that has the last element. So now it will take away from the stack. That is the meaning of pop S. Now again I am pushing S comma E. So what happened? Now the C last element, this is the last element. So this will be popped out, and now my series will become like this: A, B, and then E. Because we are popped out to the last element and we are fetching the new element. Now again if you are giving pop S, next this operation will eradicate this E. So this will be popped out now. So this is the major scenarios that happens when we implement it through the programming structures. Next we deal with the diagrammatic representation. See, here I am just given you the oral concept, and now I am just giving you the diagrammatic representation, how they are fetched here. So C will be popped out, then now E will be given. So now E becomes the fourth places, and here the linked list operation, how it is a linear list and it will be implemented like this. So each and every stack will be portrayed through the arrays, and array can hold the item that will be processed here. So we can use this linked list with the process of making this allocation, that is head and then tail with a header, next header to be pointed out, and linear list will be processed like this. And this is our stack linked list. So when we have the stack implementation, linked list will be followed and everything will be given from the first array. So the header position will point out the data, and later on each tail and every element to be processed with the proper notation. And now I am just going to give you how it is implemented. Say for example, my array implementation or stack implementation or vector level or linked list level, in these three levels the stack can be processed, but we should understand how they are implemented, how it is possible to hold the memory allocation from the stack to maintain all this data. All these things will be given you the entire thing. So my next slides will give you the explanations about these implementation levels. So this is our major contributions, what is advantages and disadvantages. See, as you know that memory allocation will be held for each data item. The major thing is it has a fixed size. We cannot give them dynamic allocation, and we cannot give them memory allocation that put on to the real world application. So this is a major disadvantages in the stack. So here I have a fixed size and the best performance, it will give you the best performance, but in the case of memory allocation it was in the very reduced size. So this is the disadvantages. So if gate questions point out about these scenarios, that is like multiple choice, if you expected the questions like this, you can give them a proper reason that it won't maintain the dynamic allocation. Okay, you can expect the questions like this. Okay, next. These are the basic implementation where it is applied. So for example, if you have an empty array, you can maintain. If you have a pop method, you can have. If you have the push method, we can have the malloc. So all these things will be utilized with the proper methods. But when we have the memory allocation, it was very limited. And this is the way how the real world applications are utilized. Say for example, I have a pile of books. We can have a trace of arrangements. All these things can have utilities over the stack. and it will be holded like that. But when we have the program execution, we can use the stack. When we have the expression syntax, say for example infix to postfix. In my next slide I am explaining that also, that is infix to postfix, infix to prefix, prefix to postfix. For all this expression evaluation we can use stack in a very efficient way. So it will be useful for you to have a good implementation for using this, utilizing these expressions. Then parsing and function call, all these things will utilized through the stack. And this is our example. So here I just want to give you the topic where the each and every concept will be perfectly moduled. See here, first step, when we go the first step, the push method will take a process of analyzing the data and it will be saved there. So first element is green, second element is blue, so this will be pushed there, and fourth element is red, this will be popped here. So when I am giving push and pop, automatically all these elements will be fetched out. Say for example, if I am giving push here, the red will be pushed here. When I am taking pop, the red will be popped, and then if I am giving red, again it will be pushed. If I am popping pop, again the green will be popped. So these are the methodology that happens in the stack. Next, there is a two possibility, that is we can implement the stack. It is not a restricted one that the memory should hold only one stack. We can have two stack. So two stack in the way we can have two top elements. So once I am declaring integration of any two applications, I can take one of the implementation from other stack and I can use those data in the another stack. This is possible when you are using the stack processing operations. And then this is how the entire conceptual meaning will be deployed. Say here I am having conceptual matters and I am having physical node. So here when we have these things, see here this is what we maintaining as a conceptual level, but physically it will be implemented in this level in data nodes. Say here when I am linked list, the count of 5 will be given like this. Say this is 1, this is 2, this is 3, and this is 4, and this is 5. So all my 5 nodes will be topped with every allocation in the memory location. So this is the physical levels of memory allocation while we are processing the stack, but this is the conceptual way which we are learning as a theoretical part. Next, how it is linked. I told you that it is a linear list and we can implement it through array and linked list concept. So linked list, when we are going that, the data will be here and the next link will be processed here. So as you know that linked list process will be had with the header and the tailor position. So tailor in tail node we are giving the next link node. This is also possible in the stack and this is maintained for the entire data structures. And this is what the implementation process here. So this is the way how we are implementing the process. Say for example, if I am starting the stack, it will be count and it will be use the top. This is the entire stack implementation, that is pushing the element. Whereas in node, which node we are processing, this will be processed like this. So in programming structure, we should give node, data, link and then end node. So this data and link will be the part of your programming structure. Next, this is our expression view. So when I am holding the expression, I can change it via the stack implementation. So here I gave the 3 important example that you can easily understand. So plus AB, infix A plus B and postfix is AB plus. So this is by nature we cannot move down that infix to postfix or any expression conversion, but through the stack it is very easiest way to have a major look of infix to postfix. Say for example, we have 2 methods, one is manual method and another is a stack method, and this is what I just going to give you the explanation. As a count of thing, So this is our overall expression. So A plus B star C minus D slash E. So when I am giving the pop or push and pop operation as an alternate method, the stack will holds the entire thing with a step-by-step process. Say for example, our stack will have the top position. So first the A will be fetched here. So as you know that the operands will be considered to be the last one. So here A, next level is A, B, and then A, B, C. So see the step-by-step thing. So the literals will be processed as a first step, and then later on operands, and operands will be in the process of like a boolean, like a mathematical thing. It will be processed with the BODMAS operator. So it gives higher priority for the divisions. So here first it will process with the star and then arithmetical operation. So star and then the division and minus and plus. So here when you are tracking the stack through these levels, the postfix, infix to postfix or infix to prefix, all things will be familiarized with the stack method, and it is one of the easiest method to find out the calculations through the stack implementation. Next, this is a one simple example that you can easily understand. Say for example, this is our implementation. When we have infix, the operand should be in the middle position, whereas in prefix it should be in the top position, and then postfix it should be in the last position. So this is a major simple example, and here I come up with an example called 2 star 3 plus 4. So as a BODMAS rule, first multiplication should be done, then the plus operator. So here it will process like this. So first it will take 2 star 3, then plus 4. So here it will give like this 2, 3 and then star, their operand to be in the next one, then the 4 plus. This is the postfix conversion. Whereas in prefix it should be processed first. So here 2, 3, 4. This operand, all the operand will be come first, and then the postfix will be divided like this. So when you are taking the chance of converting this infix to postfix, the stack will have a maintenance of all these things in the array terminology, so that linked list or array, whatever we are implementing the data structure, the stack will be the easiest method to have this level of implementation. And this is about the summary session. I conclude you that the stack will be implemented via the linked list and array, and we here in this video we focus on how to have the push and pop element, and we have a extension of how we can do the infix to postfix. So today we have a very good enhancements about the stack, and now I am just going to give you what are the expected questions through the gate, and I have gathered with questions, some sample questions from 2025 gate exams, and here we can expect the data structures stack implementation with the 3 levels. One is infix to postfix, another one is about the theoretical part, and another is about evaluation of expression. So first I focus on the thing about changing the postfix expressions, and here they have given the operators and given you the explanation of precedence. That is, they have given the highest priority, which should be highest priority, and which will be the operators and what will be the operand. All these things they have summarized like this, and they have given the infix expression like A plus B cross C minus D. This is the expression. So here they want to have the postfix conversion of a postfix expression, and here we need to implement what we have learned in the previous chapter. So here just we have to give the summarization of operand first and then operator in the second row. So now we can expect the answers to be in this range, and we need to have a depth knowledge about that. Just we have a glance of going through the infix to postfix, then we can have that answer, and as part of the implementation we know that the answer is A. So here the operator will be operator will come first and then operator. So this is the best choice of preferring the stack implementation. Then the second question we can expect like this, that is, they have given the expression now and they will give the values also. Now we have to evaluate that with the proper implementation. So here they given the expression like 105 plus 606 operand and then the operator. So when we have these things, it is in the postfix level, and now we have to implement that with the stack implementation. So first, regarding these things, when you are evaluating this operand first and then operator, then now the answer will be third one 142. So this is the best example for receiving gate questions like this. And then the third example, I just given you the sample of getting a theoretical way, that is analyzing way. So when you are having an analysis part, they will ask you which type of thing is arithmetically expressed through the theoretical part. So now we have a chance of giving this in a very easiest way, and you know that the answer will be stacked because they are getting the data structure value with the best implementation for arithmetic expression. As I detailed explained to you, like arithmetic expression will be processed only with the stack implementation. The answer for this, the solution for this question is stack. So here we can expect the questions like this in this way, like expression conversion, then value implementation, and then theoretical part. So when we have a stack in a very deep way, we can able to answer at least 3 questions in the gate coaching exams with the proper explanations. Thank you, and we will meet you in the next video. Thank you.